Welcome to Gumber's Mathematics classes. Hope you liked the video. Subscribe our channel and press the bell icon to never miss another updates.
Hello everyone, I hope you all are well. Today we are going to revisit rational numbers and their decimal expansion. As we know, rational numbers are the numbers which can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. Now, decimal expansion of rational numbers are either of the two forms, that is maybe terminating, or if it is non-terminating, then it is repeating. Let's go through a theorem. Let x be a rational number whose decimal expansion terminates. Then x can be expressed in the form of P by Q, where P and Q are co-primes and the prime factorization of Q is of the form 2 raised to the power n into 5 raised to the power n, where n and m are non-negative integers. Now, in the usual language, I would like to explain it again. If we are talking about rational number and its decimal expansion terminates, then there would be a very special property about the denominator of that rational number, that its denominator is of the form of prime factorization as 2 raised to the power something and 5 raised to the power something, and these m and n are non-negative integers. Could be 0 also, could be any positive numbers also. Next theorem. If this is the converse of the previous theorem, let x is equal to P by Q be a rational number such that the prime factorization of Q is of the form 2 raised to the power n into m raised to 5 raised to the power n, where n and m are non-negative integers, then x has a decimal expansion which terminates. Earlier we started with termination and we reached up to 2 raised to the power n into 5 raised to the power n. Now they are saying that if the denominator of a P by Q form of a rational number is of the form 2 raised to the power n into 2 raised to the power m, 5 raised to the power m, where n and m are non-negative integers, then the expansion of that decimal expansion of that number will terminate. Next is, the main point of this is, don't forget to convert the given number into its lowest form, as it was clearly mentioned in the previous theorem also, that P and Q are co-prime, means there should nothing should be common between P and Q. Now let's have one more theorem about that. Let x be of the form P by Q, where P and Q are co-primes, be a rational number such that the prime factorization of Q, that is denominator, is not of the form 2 raised to the power n and 5 raised to the power n, where n and m are non-negative integers, then the decimal expansion which is non-terminating. Now we have finally we have come to know the conclusion that if it is of the form P by Q and Q is having some another factor other than 5 and 2's power, then the expansion of that decimal expansion of that number will non-terminating repeating. Let's discuss one or two examples for that. So we are discussing very first example, that is 35 divided by 50. 35 divided by 50. So very first we are supposed to convert this into its lowest form. There should be no any common factor between them. So we can get it as 5 divided by 5. So this is 7 by 10. Now as this denominator is just having factors 2 and 5, therefore it has terminating decimals. And we can convert this into decimal form also, and this is 0.7. This is terminating decimal. Now let's consider one more example, 3 by 8. 3 by 8, as its denominator is having factors as 2 raised to the power 3. Only 2's power, therefore this also terminates. Now how to convert this into the decimal form? We can write it as 3 divided by 2 raised to the power 3. Now we will try to make the equal powers of 5 and 2. We need to multiply it by 5 raised to the power 3 in numerator also and denominator also. Now we are getting 375 divided by 10 raised to the power 3, that is equal to 1000, and this is equal to 0.375. This is very easy step to convert a given p by q form into a decimal form without using actual division. Another thing, as many as the power, highest power of 2 and 3 we have, 2 and 5 we have, that many decimals after digits after decimal will be carried in our decimal expansion. Now let's consider one more example. Let us consider 1 by 3. Here, this is not having, or we can consider, this denominator is not having 2 and 5 only, it has 3 also. So this is having 2 raised to the power, this is 1 upon 3 raised to the power, 3 raised to the power 1. It is not having 2 and 5 only, it has 3. Therefore, its decimal expansion is non-terminating. So as we know, this can be written as 0.333 dash dash also, non-terminating repeating decimal. Thank you. Stay at home, stay safe. Bye-bye.